You invest 1,000 euros at 6% per annum, compounded quarterly. How long will it take this investment to increase to 2,000 euros? And again, yes, a graphical method will solve this perfectly well. It is a calculated question anyway. But what I'm trying to do is show you how you can do this with logarithms. So you can still consult your formula book and find the future value for compound interest equation, which says FV equals PV times 1 plus R over 100k, all to the power of Kn, where FV is the future value, PV present value, N is the number of years, K is the number of compounding periods per year, in this case 4 as it's compounded quarterly, and R is the nominal rate of interest, and it's actually the whole of it. R is 6, what it isn't is 0.06, which it might be if we used an exponential model for continuous interest. So what we're going to do, write everything we know down. We want it to increase to 2,000 euros, so that must be our future value. So 2,000 equals, the present value is 1,000, open the bracket, so 1 plus R, we said was 6%, over 100, K is the number of compounding periods per year, it is 4, times 4, and then the how long is the bit we don't know, so I'm going to put K N, so 4, K is 4, I'm going to put 4N. And that, when we do that, when we get an answer, N will be in years. If we didn't put the 4, then it would potentially be in something else. So if we do as much as we can certainly divide through by 1,000. So 2,000 over 1,000 equals 1 plus 6 over 400 to the 4n, so that would be 2, equals 1 plus 6 over, I could call that 3 over 200 to the power 4n. So now is a good time to get the logs involved. So I'm going to take logs of both sides. So that would say ln2 equals ln 1 plus 3 over 200 to the power 4n. Now don't forget, I could have done that in base 10. It wouldn't give me a different answer. It's not the same as like using an exponential model for compound growth. It's not. That's not what it is. It's just you're literally just using a log. Whatever base I do this in, it will give me the same answer. But if you look on a mark scheme, they're going to expect you more often than not to use natural log. You'd probably get away with base 10, but don't do things like use a base 2 and then use your calculator for that. You might not get the recognition for that. So now we're going to use the third law. Going to get that 4n out of there. So that would say ln2 equals 4n times ln 1 plus 3 over 200. That's, close the brackets. So now we can make this 4n the subject. 4n equals ln2 over ln 1 plus 3 over 200. So n is going to be ln2 over 4 times that. N equals ln2 over 4 ln 1 plus 3 over 200. So now we can go to our calculator and we can get an answer for this. ln2 over 4 ln 1 plus 3 over 200. 1 plus 3 over 200. Make sure we close the bracket in the right place. And that gives us an answer of, it tells us n equals 11.0 0.64-ish. And now we need to recognise that this thing was kind of, in the context of the question, this was a compounding quarterly, so really we need this to the nearest 0.25. So n really needs to be greater than or equal to 11.75 years. Okay, so it's going to be 11 3/4 years. 11 3/4 years, or I suppose that would be 11 years. There are 12 months in a year, so it must be 9 months.